So we're changing gears and we're looking back at absolute values. Now, technically, absolute values are an Algebra 1 topic. So if I'm going to cover them in Algebra 2, I'm going to cover them at the Algebra 2 level, which means we're going to take all those transformations we just talked about in Lesson 4, and we're going to do all of them in the absolute values, which is a little more than we usually do to our Algebra 1 kids. Everybody good? So there is one thing we do a little bit differently with absolute values than with any other function when it comes to transformations. Before we do that though, let's list out what transformations are taking place here because it's important for us to understand that. So take a look at this equation. Tell me a transformation that's happening to this absolute value graph. Okay, so it's being translated down 2. Are we cool with that? How do I figure out how it's being translated left or right? What do I do? Okay, so if there was no number directly in front of the x inside the absolute values, then I would say it was translated 6 to the left. And it is technically translated 6 to the left, but then it's being what? After I translate, what else is happening? That's on the outside. I'm still talking on the inside. What else is happening to x? Multiplying by 3 does what? So that is a horizontal compression by 3. So if I translate 6 to the left, but then I compress by a third, how far did I really translate? Only 2. So we're going to take that 3x plus 6. We're going to set it equal to 0, and we're going to solve for x. So what would I do first? So I have 3x equals negative 6, and then divide by 3, and so x equals negative 2. So it's translated down to and left 2. Those are the actual translations that end up happening. Are we okay? All right, now, we just said it's being compressed horizontally by 1/3, right? It's going to be horizontally compressed to a third of its otherwise width. Are we good? Okay, then, what else is happening? It's being reflected over which axis? Yes, over the x-axis. If I'm changing the output, it's because I'm going vertically. So I'm being reflected over the x-axis. One last transformation. Vertical compression or shrink by 1/2. Okay, so if you imagine an absolute value, if you compress it vertically, it's going to get wider. But if you compress it horizontally, it's going to get narrower. So if I'm compressing in both directions, they're partially canceling each other out. Does that kind of make sense? Okay, now they're not completely canceling each other out. That would happen if like it was 2.5 or 1/3 and 3, right? Then they would completely cancel each other out. It would be like nothing actually happened. But these are not completely canceling each other out. So it gets a little bit confusing when we're trying to think about what would that look like. Now, when I deal with any shape other than an absolute value, I have to make the parent function table and multiply the different sides by the different things. But with absolute values, there's a little bit of a cheat because fundamentally an absolute value is 2 lines that you each keep half of. Does that make some sense? And because lines have slopes, there's a cheat we can use for how to accomplish this. I have a stretch and I have 2 different compressions going on. And the cheat is that you can multiply the 2 A values together. So the slope is going to be 3/2. And this only works for absolute values. I mean, technically it would work for a line, but no one transforms lines. That's just weird. We just graph lines. We know how to graph lines from all their forms. Okay? But all the other form types of functions we transform, absolute values are the only ones that have this cheat where you multiply the 2 A values together to get what the slope is. Yes?
Why would the slope not be negative? Is the negative just to represent the shift over the x-axis?
So it's a good question. Why is the slope not negative 3/2? Picture an absolute value. It's two lines. One line has what kind of slope? A positive slope. The other side has a negative slope. So we never bother to say that the slope is positive or negative because we understand that the slopes are both positive and negative. It just depends which side you're looking at. Does that make sense? Okay. Everybody good? Okay. So when we go to graph this thing, an absolute value that had not been translated would look like that, right? Where would its vertex be? 0, 0. But if I translate it, the vertex goes where? Down 2 and left 2. So my new vertex is -2, -2. So when I go to make my graph, I want to think about where I should place my axes so that I make the best graph possible. So first of all, which way does this absolute value open? Down. So from wherever the vertex is, it's going down. So where should I put my x-axis? Up pretty high, like near the top. Near the top, not at the top, because we always want to be acknowledging that there are in fact 4 quadrants. So I'm going to come down like one line from the top, because I don't need any space up there. Now my y-axis, should it be right in the middle? Should I move it? What should I do?
It should be like a bit closer.
Yeah, since my graph goes a little bit to the left, I want to move my axis a little bit to the right so that my graph is like in the middle of the space, using the space well. So I'm going to move my y-axis a little bit off to the right. We doing okay? All right, so now I can start graphing. So we said that the vertex would be at -2, -2, so I can go make that point. We also know that it's going to open down from there, so I can go ahead and label above that point. I know it won't be in the way. That way I don't forget to label. Then we said we can use the cheat for absolute values of a slope of 3/2. So we know we're going to go down 3 because it's upside down. And then I'm going to go out 2 to each side because we know it's symmetrical. Okay, so I'm going down 3, out 2. And then from there, I can go down another 3 and out another 2. And down another 3 and out another 2 until I run out of space. Then I can draw the rays. I'm going to make sure my rays go all the way through my points, that they're straight. That side one was so not straight. Let me try that again. And that they have arrows on their ends because they do continue downward and out to the sides forever. Just like a parabola, I need to label the vertex and 2 points on each side. We okay? All right, so what are the coordinates for this point here? 0, -5. And the next one down the line? 2, -8. Now, once I know my y values, I only have to figure out the x values on the other side. So across from 0, -5, I have -4, -5. And across from 2, -8, I have -6, -8. I now have my fully labeled, properly graphed absolute value function. Questions for me? We're good? All right. One last notes problem for today. What's different? There's an inequality. So inequalities require what beyond what we already did? Shading, right? Exactly. And we've done this before. Back in chapter 1, we had inequalities when we did linear programming. So you're going to bring back that information from unit 1 when we had our inequalities. So just looking at the symbol, where am I going to shade? Above, right? I'm going to shade above because that's where the y values get greater. What else do I have to remember? Because it's a greater than and not a greater than or equal to. Don't draw a solid line, right? So, and it's going to be a dashed line. I know that before I do anything else. So I want to keep that in mind when it comes time to graph. Now, conveniently, this inequality is a little simpler than the problem we just did above, right? There's not quite as much going on here. So let's plan it out the same way we did before. Which way does this absolute value face? Up, because there's no vertical reflection. Everybody good? So I know I've got an absolute value that goes this way. Okay. Faces up, no reflection. Do we have any stretches or compressions? What do we have? Vertical stretch. By what factor? By 2. Okay, so that tells me that my slope is like 2 or 2 over 1. We know that one side's positive and one side's negative. Good? All right. What about translations? Are there any of those? Yeah. So where is it translated?
To the left.
All right. Translated 2 left and 3 up. Everybody's cool with that?
Could you also write in T sub?
You could totally, instead of writing this, write T sub negative 2, 3. So if you like symbols instead of words, that is cool with me, as long as you use your symbols correctly. We're good? All right. So let's think about axis placement again. This one opens up from negative 2, 3. Where should my x-axis go?
Closer.
Close to the bottom, right? Because there's nothing really important down there. So I'm going to put my x-axis down here. All right, y-axis. A little bit to the right again, because just like the last one, we have a translation 2 to the left, so our axis moves a little bit to the right. Okay, so I'm going to go ahead and put my vertex in at negative 2, positive 3. I'm not going to label yet, because right now, I'm like, I know I'm going to have to shade, and I want to make sure I'm labeling in a way that works with the shading, so I'm going to just hold off on a minute, okay? We said our slope was 2, so that means I go up 2 and out to both sides 1, all the way across the graph. And remember, we decided before we ever drew anything that this line needed to be dashed, so we're going to make sure to draw a dashed line. I will tell you, everyone always forgets, which is why we graph in pencil, and you can just erase the dashes into your line, and that's totally fine. But that's why you graph in pencil and you don't graph in pen. Everybody good? Yes, we're okay? All right. We said we were going to shade above, and sometimes kids get a little confused by that when they have shapes that are not lines. So here's what you can imagine. If I'm shading above, imagine that this absolute value is in the movie Up, and we put a whole bunch of balloons on the line and let it start floating up. Where it floats is where I should shade. So my shading ends up being above like this. We communicate that the shading goes on forever by going all the way to the edge of the graph, because I can't put tons of arrows on my shading, right? With a line, I can say this keeps going up by just putting arrows. For shading, I go to the edge of the grid, and that communicates this keeps going. Now I can see I have plenty of room around the outside of this graph to go ahead and label my points. How many points do I need to label? 5. Which one absolutely has to be labeled? The vertex. So I'm going to label that one first at negative 2, 3. Now from there, it's up to you. Personally, I don't really feel like I have space to label the point that's at negative 1, positive 5. I don't really have room. The axis is kind of in my way. So I would wait, and I would label 0, 7, because I have room over there. Does that make sense? All right. And then, once I'm there, I'll probably label the next point, which is what? 1, 9. Yep. So if I just labeled 1, 9, I probably want to label the points that are across from that, right? So what's across from 1, 9? Negative how much? How much? Negative 5, 9. And the point that's across from 0, 7? Negative 4, 7. Usually people like to label symmetrically. People usually don't like it when I label asymmetrically, so I won't. Everybody good? All right, that's it. Oh, wait, not quite it. There was some other stuff that they asked us. Now, we did it out of order. It says without graphing. But we planned it all out before we graphed. We already knew what the vertex was going to be. What was it going to be? Negative 2, 3. Now, here's something we have not talked about. I hope you talked about it back in Algebra 1, but maybe you did, maybe you didn't. Axis of symmetry. I know you talked about symmetry back in geometry. What is a line of symmetry?
It's a line where you can cut it exactly.
Okay, so a line of symmetry is a line that if I cut an object along that line, the two pieces could fold right on top of each other. So where is the line that if I cut this absolute value on that line, the two pieces would match up. Where is it? X equals -2. It's always going to be the vertical line that runs right through your vertex. That's true for both parabolas and absolute value graphs. Same deal for axis of symmetry. Are we cool? All right. And then we already identified the transformations. We already know that the parent function is? What's the parent? Y equals the absolute value of X. Are we good? Yeah?